Okay, so this is lecture number 2, lecture number 3. So, in this again we are going to see some of the soil properties. So, as I mentioned mostly the soil structure, bulk density and particle density, and then other properties like void ratio, porosity, okay, so the other things. Okay. So, this is a soil structure. So, soil structure, so this is basically the arrangement of soil particles in a soil. So, in the previously what we saw was the soil constitutes sand, silt, clay, right. But at the same time if you see, so the individual soil particles are going to arrange in a definite shape, all right. So, so that is why the arrangement of soil particles are very important when you are talking about the water flow, right, and then the effects of basically this is going to affect root penetration and water intake moment. Okay. So, that is what the arrangement, the soil particle arrangement is very important, right. So, the soil structure together with the soil texture affect soil pore size and pore distribution and thus the porosity of the soil. So, the for example, you have like sand. Okay. So, sand has definitely compared with other textures. So, right. So, sand has bigger particles, right, compared to other. Okay. So, then if you have a soil structure, suppose these particles are arranged in some fashion. So, definitely, so this individual soil texture and also the arrangement of these individual particles. So, definitely influence the pore sizes, okay, the pore sizes and also the pore distribution, and definitely that is going to ultimately influence the water movement. Okay. So, for example, in case of clay versus sand, so clay the porosity is going to be smaller, and sand and the pore space is going to be larger. So, definitely the water freely moves into the pores compared to the clay soils. So, let us see here macropores, sorry, micropores. So, this is helpful to retention of water and solute, okay. Whereas macropores which are bigger than micropores definitely helpful in infiltration and drainage and aeration, okay. So, the macropores what we are talking mostly due to dead roots or rodent holes or maybe any cracks, all cracks. So, or so mostly it depends on the bigger pores, it causes bigger pores. Okay. So, then next is, so as I said the soil structure. So, arrangement of soil particles. So, the soil particles could be arranged in a granular structure, right. So, if you see these all are like well definite shape, they are closely arranged one by one. So, like attached to one to other. So, this is kind of if you see some kind of biscuits, okay. So, like a porous biscuits, it looks like this, the crunchy biscuits, okay. Whereas here another arrangement of the soil particles could be in a blocky. So, like all like a block shapes, small blocks, okay. So, like one by one the blocks are arranged one by one, okay. So, this the one block contains number of soil particles, it is not one soil particle, okay. So, that is why these soil particles are arranged in this blocky manner. Similarly, so the soil particles like arranged in a prismatic manner. So, it is like a prisms, right, and soil particles are arranged in platy structure. So, these are the plates, right, the plates. So, so here the problem is if you see the water movement. So, horizontal movement could be possible, but vertical movement will be difficult in this case, okay, from here to here because the plate. Okay. So, here this is column structures, right. So, the particles are arranged like a columns, like a columns. Here massive structure. So, if you see, this is the ground. So, sometimes the massive structures are like big cracks, big cracks is kind of a pellet. So, all soil particles are arranged in a big chunks, big chunks. So, here what we observed in this is, so soil particles can be arranged together and to form a different shape like a granular, blocky, prismatic, platy structure, a columnar structure, massive structure. So, how these structures are going to influence the water movement. So, that is our main intention here. Let us see. So, in this picture it is clearly showing. So, in case of granular structure, or single grain or granular structure, so the water flow is really rapid, right. This is very rapid, even the granular structure also it is rapid. Whereas, the blocky structure if you see, the water flow is moderate, okay. Water flow is moderate because of the blocks. And then platy structure it is very slow because you got the plates in this direction, right. The plates are arranged stacked one by one. So, vertical movement will be slower here, and prismatic also the moderate, and massive which has big chunks. So, the water is only passed through the cracks basically. So, the otherwise it is very slow. Once it is moving through the the massive structure, the water movement will be slower. So, definitely this picture shows the how the soil structure is going to influence the water movement. Okay. Yeah. So, the next is how to estimate some of the properties like. So, here I am going to show what is a bulk density. Okay. So, here if you see, this is a bulk density, and finding out how to find out the bulk density of a soil. So, what is the bulk density? What is the density? So, density is mass per unit volume. So, you have a volume of a particular material, right, and or you have a material which is filled in a glass. Okay. If you know the weight of the material which is putting in the glass or and divided by glass volume, that will give the density of that particular material. So, since it is bulk, so this is bulk density you can say. So, similarly, so soil has this physical property called bulk density. So, if you put soil in any the glass, so knowing the soil mass weight divided by glass volume will give the bulk density. So, here but in the field how to estimate this? So, this is called bulk density measurement kit. So, this is a kit generally we will use to take off the samples. So, as you see here the different pictures. So, the first you have to dig out hole using an auger. Okay. So, the once with auger reaching a particular what you call the soil depth. So, suppose you want to take measurement at 15 centimeter soil depth. So, that you want to find out the bulk density at 15 centimeter depth. So, using soil auger you take out the soil up to 15 centimeter. Okay. Then put the insert. So, this is called, if you see the different cores. Okay. This is the soil cores, these are the soil cores. Then so, soil core will have so this kind of a thing. So, here you will be mantling on top. So, this will have a core of cylindrical core, like once you take out. So, you are going to have this kind of cylinder with soil. Okay. So, at 15 centimeter depth, So, using the soil core, take out the soil core. So, like this, and protect it or put the caps on both sides, right, and take out here and find out what is the dry weight of this soil, dry weight of the soil which is inside the cylinder or core, inside the core. Okay. So, now knowing the dry weight, how to find out the dry weight? So, here this is called hot air oven. Okay, this is called oven. So, put the material which is brought from the field to a oven at 105 degrees Celsius for 24 hours, then you will get a dry weight of I mean the moisture will be completely dried, and you get the dry sample and find out the dry weight. So, that is the MS. MS is the dry weight, and since you know the soil core, so the soil core will have the length and it has a diameter, right. So, knowing the length and diameter, you can find out volume. So, the volume V is equal to pi d square by 4 into L. Okay. Pi d square by 4 into L. So, this is area and length. So, that will give the total volume. Okay. So, then you will get the bulk density. The units are gram per centimeter cube. Okay. So, this way you can find out the bulk density in the field. Sorry. Okay. And now, the next thing is finding out the particle density. Okay. So, particle density in the sense, so the bulk density that as such will contains the pores, right, as I mentioned initially. So, the soil will have the solid particles like solids as well as some gaps or some voids. So, that will be like filled with water and air. Okay. So, whatever you measure the bulk density, so that includes the water, air, sorry, the gaps, what you call that, voids, right, or the pores, it contains the pores, then that is the bulk density. So, but particle density, so exactly the mass of soil divided by the volume of solids. Okay. So, here what we do, we only consider the volume of solids. Okay. So, not the total volume, not the total volume. So, how to measure this particle density in a laboratory? Okay. So, here, so this is the measuring cylinder, right. So, not measuring cylinder, this is the measuring jar, you can say. So, find out empty weight. So, that is M1. So, that contains the a bottle as well as the stopper. Okay. So, then add this soil and find out the weight M2. Now, add water and also add water into that and take out the air gaps, whatever it may be, some air, because soil contains porous space that maybe the air might be hiding. So, you have to take out that by using by vacuuming. So, take out that one, and then after making up to 1000 ml, right, 1000 ml. So, find out M3. So, you got M1 with empty, M2 with some soil inside, and M3 with soil plus water. Okay. And then M4 is completely water up to 1000 ml. Okay. So, now the calculations, if you see, the particle density which is equal to M2 minus M1, that is soil. So, this is the soil, dry soil, right, and M4 minus M1, M4 minus M1. So, this one and this one, this will give what? This will give total water occupied by 100 ml. Okay. And M3 minus M1, M3 minus M1, So, this will give what? So, this will give sorry, M3 minus M2, M3 minus M2. So, this will give the amount of water which is occupied by the soil, okay, amount of water which is occupied by soil. So, the rho s which is equal to this is a dry soil. So, that is M s, and so this difference, whatever difference you are seeing, that will give the volume of water equivalent to the dry soil. So, here we have taken out the voids out, okay, taken out the voids out, that is why there is no chance of air gaps in the measurement, otherwise that would be equal to your bulk density. Okay. So, here the particle density ultimately you get M2 minus M1, M4 minus M1 minus M3 minus M2. This one is the specific gravity of water or density of water. This is the density of water, right. So, this way you can estimate the particle density. So, generally the particle density varies from 2.6 to 2.7 gram per centimeter cube. Okay. So, next is your basic soil water relationships. So, once you have this volume, right, if you see here this is a picture. So, as I said, the soil will have the solids and water and gases. Okay. And if you find this is the total volume V T, so that includes the gaseous volume, water volume and solid volume, and individual volumes are V s is the volume of solids, V w is the volume of water, V g is the volume of gas. And similarly, the other side, so this side these are the masses, okay, masses. So, here M s is the mass of solids, M w is the mass of water, M g is the mass of gas. So, generally we consider the 0 and the total mass is empty. So, with this information we are going to define some relationships. So, the bulk density, so from this picture if you see, the bulk density will be equal to, so MT not MT. So, we are going to do that, but basically let us see. So, V T is equal to V s plus V w and V g. So, volume of solids, volume of water, volume of gas. So, then total mass is equal to mass of solids and mass of water. Okay. So, there are 7 measurable quantities you can I mean it all includes 7 measurable quantities. So, commonly used relationships are derived from these quantities. We are going to see what kind of relationships are. Okay. So, you go to the next slide if you see. So, the first thing is as I mentioned. So, this is the dry bulk density or the this is the particle density and this is the dry bulk density. Okay. The particle density which is mass of solids divided by volume of solids. Okay. So, mass of solids in the grams, volume of solids, that is in centimeter cube, and the value 2.6 to 2.7 gram per centimeter cube. Whereas, dry bulk density, so mass of solids divided by total volume of. So, the main difference is from here and here. So, the mass is same. So, mass of solids same. The only difference is here we consider volume of solids, here the total volume in case of dry bulk density. Okay. And typically the values are 1.1 to 1.6 gram per centimeter cube per soil for soils, whereas if you see the cotton, right. So, the cotton generally I mean it will be like 0.08 gram per centimeter cube. See how, because the cotton is very light compared to the soil, right. So, but this is the bulk, okay, this is the bulk, and see the density 0.08 is very light compared to here. If you put both in water, So, the cotton is I mean generally if is going to float, whereas soil is going to drown, right, or sink, can say. Okay, so the next slide we are going to see the relationships basically. Okay. So, here the total bulk density or the total wet bulk density. So, dry bulk density, wet bulk density, what is the difference? The difference is if you take dry weight of soil, that is dry bulk density, if you take wet weight, I mean solids plus water. So, that will be wet bulk density. So, if you see here wet bulk density, so this is mass of solid including water. Okay. If you see the mass of solids plus mass of water. So, this one and the total is same, just like your dry bulk density case. And the porosity will be the volume of voids divided by what total volume of total volume. Okay. So, what in case of porosity you are targeting, suppose, so this we are looking into this voids, okay, this voids. So, volume of voids, so volume of these voids, volume of voids and divided by the total volume will give the porosity, okay, that will give the porosity. Then you have void ratio. So, void ratio is, so how the ratio of volume of voids and volume of solid, okay, volume of solids. So, how proportionate? So, solids, how proportionately this volume voids and solids are in a relationships. Okay. So, here VO, suppose you have the soil which has soil particles, right, and this is the void, it does not contain any solid particles. So, I mean this is VV. So, this is volume of void divided by and combine all soil particles, right, all soil particles, that makes volume of solids. Okay. So, this will give the void ratio E. Then the specific gravity of solids. So, this is specific gravity. So, that means ratio of density of solids to the density of water. Okay. So, this is the density of solids divided by density of water. So, that will give the specific gravity of solids. Okay. And then we are going to see the next slide, a few more relationships. So, here, so this is water in the soil, how much water is present in the soil, we call the soil moisture. So, that is called soil moisture. Okay. Soil moisture is the percentage of moisture which is present in the soil, amount of moisture present in the soil. So, soil water can be estimated here using moisture probes or gravimetry, basically gravimetric method. So, here the soil water content in dry basis is equal to mass of water divided by mass of solids. Okay. And similarly, soil water content wet basis, so mass of water divided by mass of solids and mass of water. So, here this is only see dry weight and this is a wet weight. Okay. This is a dry weight and this is a wet weight of sample. Okay. So, and then so this is where we find out dm is the mass water content dry basis, theta Wm which is mass water content wet basis, and Ww, that is mass of water evaporated. So, mass of water evaporated, that is grams, and mass of dry soil. Okay. Ms is mass of dry soil. Suppose you have taken a sample, soil sample, wet soil sample from the field. Okay. So, find out that weight. Okay. So, that weight will give you what? This is a mass of, this is the total mass Mw and Ms. Okay. So, this will get total mass. If you take soil sample directly from the field, so this contains mass of solids and mass of water. Okay. The moment if you put it in, dry it using oven, so the water is going to evaporate. So, that is MW, and the amount which is left is MS, okay, that is solids, mass of solids. So, it is only simply the the ratios, If you want to get dry weight, soil moisture content in dry basis. So, knowing the MW, how do you know the MW? So, in this case when you do weight, so that you get only MS. So, MS plus MW minus MS will give the MW. Okay. So, that MW here divided by MS. Okay. So, that will give the water content in dry basis, and then the MW divided by the total, right, the total in this one. So, that will give the soil water content in wet basis. Okay. And so, then that is weight basis, whatever we got, the soil moisture, the soil moisture. So, that in yeah. So, the soil moisture in wet basis we got. So, that is a dry basis we call. Now, how to find out soil moisture in volumetric basis? Okay. So, one is soil moisture content in weight basis, So, that's what we got. So, like theta weight basis, wet basis. So, that is equal to W divided by M W plus M S. Okay. So, this is soil moisture content in wet base. So, how to convert this into a dry volumetric basis? So, that is volume of water and total volume. So, this is the volumetric basis. So, at saturation what happened, the saturation. So, that means you have soil will have the pores, right. Since saturation what happened, these all pores are filled with water, whatever the pores in between soil particles will be filled with water. So, then that is the saturation, and that will be equal to your N. So, N is your porosity, okay, N is a porosity. Okay. So, then in order to find out the volumetric basis using the weight basis. So, weight basis needs to be multiplied with the bulk density. Okay. So, what you can say? So, theta in volumetric basis is equal to theta in weight basis multiplied by the bulk density. Okay, bulk density. So, that will give the theta in volumetric basis. So, here also, so theta v which is A s, right, into theta dm, dm is the dry basis soil moisture content multiplied with apparent soil specific gravity. So, soil specific gravity is equal to the bulk density of the soil divided by the density of water. Okay. So, since density of water is equal to 1, you will have the apparent specific gravity which is equal to the bulk density of soil. So, simply what we did, the volumetric basis which is equal to bulk density of soil multiplied by dry moisture content or moisture content in dry basis. Okay. So, and next is, so once we know the soil moisture which is present in the soil, So, how to find out the equivalent depth of water? Okay. So, what is the depth of water present in the soil profile? What is the depth of water which is present in the soil profile? So, if you know the soil moisture which is theta v volumetric basis, and the soil depth is L, and this is the area in the sense you have three dimensional suppose. So, this is area. So, then finding out the volume here, right. So, theta v, because this is the volume basis, theta v into area multiplied by L. So, this will give the total volume of water in the soil, right. So, divided by area, if you can divide by area, then you will get theta v into L. So, which is the water available in this soil, I mean depth of soil, L depth of soil. Okay. So, that is theta v into L. So, what happen if suppose theta v is 100%, theta v is 100% into L. So, that will give. So, because 100% means what? There is no soil present in the this is kind of a cube, right. In a cube there is no soil, then what is the amount of water? So, that will be your volume of water occupied by the cube. Okay. So, that is simply the area multiplied by length L, since your theta v is 1. Okay. So, since this is soil is occupied and only the fraction of solids, the fraction of voids, that represents the porosity. Okay. So, that is the reason we do not put 1, instead of that we put the theta v. Okay. So, that is the fraction of space available for the water to occupy. Okay. Right. So, this is this is the way we can estimate the equivalent depth of water. Okay. And the degree of saturation here, which is equal to volume of water present in the total pore volume. So, degree of saturation, suppose your soil, okay. So, your the total volume is V, volume of soil is V, and some portion which is wet, some portion is wet, okay. Some volume is wet. So, the volume of water which is available divided by the total volume, right, total volume that will give this, not total volume, volume of voids basically, volume of voids. So, that will give the degree of saturation. So, volume of water divided by volume of voids. So, that will give the volume of degree of saturation. So, I mean how much amount of the voids are filled with water. So, that will give the degree of saturation. And then, so next is this is the pictorial way of representing the available water. So, initially if you see, so the wet soil sample, so this has the soil particles, right, these are soil particles, and also the voids which are occupied by water. Okay. This is, that is called the wet weight of soil. And then when you dry it, when they dry the sample, so water is evaporated, right. So, you can clearly see the solids and voids. So, these are all voids, okay. These are voids. So, this is the dry weight of soil. Then if you can see the whole thing and distribute it. So, this is the total bulk volume, right, and I mean if you can put the water here, whatever the water which is evaporated here. So, only, and if you put that back into the, cylinder, that will occupy this much depth. Okay. So, this is called equivalent depth and this is the bulk volume. Okay. So, this way you can clearly say the amount of water which is present inside, right, present in the cylinder will be equivalent to this much of water, right, it is equivalent to water. I mean if you take out solids and solids out, so the water occupied by the cylinder is this much. Okay. So, here we have some relationships. So, we already know what is theta v, right, what is theta dm, which is a soil moisture in dry basis, soil moisture in wet basis. Okay. So, and so here F is the porosity, we can also say it is N here, and then rho b is the bulk density, okay, and rho s is the particle density. So, these are they are interrelationships. For example, here if you see F, which is equal to 1 minus rho b divided by rho s. So, how do we get these relationships? How do you get these relationships? So, if you let us put, so rho b is what? Rho b is the bulk density, is not it? So, the bulk density is mass, for example, m s, right, divided by the total volume, and whereas rho s, which is equal to m s divided by V s, right, volume of solids. So, if you can divide these, so rho b divided by rho s, which is equal to m s divided by V t and divided by m s divided by V t. So, which is equal to m s by V t into, sorry, here V s, okay, this is V s, and V s by m s. So, m s gets cancels out. So, you get rho b by rho s, which is equal to V s by V t. Okay. So, then you can say V s can be written as V t minus V v, because total volume minus volume of voids, that will give the volume of solids, divided by V t, and this will give V t 1 divided by V v by V t 1 minus. So, V v by V t, which is we call it as a porosity, okay, volume of voids divided by total volume. So, the porosity here, if you say F, okay. So, what we did, rho b by rho s, which is equal to 1 minus F, or F is equal to 1 minus rho b by rho s. So, this way you can, all have the relationships here. You can also find this relationship. So, this is F, which is equal to E by 1 plus E. So, where E is the void ratio, F is the porosity. Okay. So, void ratio E, which is equal to volume of voids divided by volume of solids, right. This is void ratio. So, let us put 1 plus E. So, which is equal to 1 plus V v divided by V s, and that will be V s by V v divided by V s, and V s plus V v equal to V t divided by V s, right. So, 1 plus E, which is equal to V t by V s. So, now the next thing is E by 1 plus E, right. Let us put E by 1 plus E. So, which is equal to E, we have V v by V s divided by, so 1 plus E, we have V t by V s. Okay. So, here if you see this is V v by V s multiplied by V s by V t. So, which is equal to V v by V t, right, this is gets cancelled. So, V v by V t will be equal to porosity F. Okay. So, the finally, so E by 1 plus E, which is equal to F. So, similarly, you can also derive, or you can also prove other relationships, right. So, remember these relationships is very important for your problem solving. Okay. So, this way, with this I conclude this lecture. Thank you so much.